Hello students, today I talk about the area based on Riemann sum and maturation by parts. This content is a little bit difficult, so I provide a story. Look at the screen. Long, long ago, there are kings and queens who wanted to know their own area and the distance from Earth to the universe, since it is indispensable for them to control their own country and read their future. So they gathered a lot of genius mathematicians to calculate the curved area and told them, how big is my land? How far is it from Earth to the star? But these genius mathematicians didn't know how to calculate the curved area. So, suppose this area of the country fx, they cut with rectangle like this. And add. But the king complained the difference between the original area, red area, and adding rectangle. This is difference. So the genius mathematicians cut more times like this. Then the difference reduced like this. The king satisfied a little bit. So the genius mathematicians cut repeatedly. As the genius mathematicians cut repeatedly, the difference decreases. Consequently, the genius mathematicians cut infinitely. Then the difference between the original area and adding rectangle was 0 almost. So the king satisfied this result. Let's follow his method. Okay. This rectangle, first rectangle with this delta x, the height is f delta x because x coordinate is delta x. So the area of the first rectangle is width times height, delta x times f delta x, plus the second rectangle, width is delta x, x coordinate is 2 times delta x because this distance is 2 times delta x. Then y coordinate is f 2 times delta x. This is height. So width times the area of the second rectangle is delta x times the height, f 2 times delta x, etc. The area of the last rectangle is, this is delta x. The height is, x coordinate is n times delta x. So the height is f n times delta x. The area of the last rectangle is delta x times f n times delta x. But this expression is so wrong. To simplify this expression, let's apply sigma and limit. Sigma k equal n to n from 1, this is 1, to n, so I can write like this, k times delta x, this is delta x, this is width, this is height, this is general form, and the genius mathematicians cut infinitely to express this situation, apply limit like this. The genius mathematicians, these two symbol change it into like this integral fx, this is fx, this is dx. This is integration. Let's look at this concept deeply by using the formula. Okay, look at this Riemann sum formula. Yeah, look at this, look at this. In this two equation, the front part is same, but the latter part is different. Let's figure out this equation. In this case, yeah. This is width, this is height, and this is integral. So we can change this form. In this function, the x coordinate is a plus k times b over n. So if suppose this is fx and the rectangle is like this, electron like this. Okay. This is first x coordinate. This is last x coordinate. First x coordinate, to find the first x coordinate, you plug in 1 instead of k. So this is first coordinate. This is, if you plug in n instead of k, you can find the last term, last coordinate. Yeah, it's like this. Considering the width b over n, we can guess this is a, because x coordinate is, this position is a plus b over n. And considering this distance is b over n times m. So this is a plus n times b over n. So divide by n, this is a plus b. So the range is from a to a plus b. So I can rewrite this is integral from a to a plus b like this. This is fx, this is dx. Okay, it is important formula, so you should memorize. Look at the second equation. Yeah. In this case, we try to change this form like this. Let's check x coordinate is b k times b over n. Yeah. Suppose fx like this. Rectangle is like this. Last rectangle is here. Okay. First coordinate is plug in 1 instead of k. So this is b over n. Last coordinate is plug in n instead of k. So n times b over n. Considering this width, this is b over n. This position is to make this x coordinate, this position is 0 because this distance is b over m. This part is divided by m, this part is b. So the range is from 0 to b. So I can change this part is integral. The range is 0 to b. This part maintain a, so fa plus x. This part is here. This part is dx. So I try to change two forms. The front form, even if the front form is same, we can change different form like this here. Focusing on the range and the function form. Memorize this formula. Let's look at this form in detail. This is width. This is height. This is adding rectangle. This is cut infinitely. So we can rewrite this part is integral. This is dx. And this is fx. The range is a and b. And it is similar. Yeah, this is in terms of y-axis. The above equation is the reason of the x-axis. So, remember this formula. Yeah, I'll give the hint when you find the reason of the x-axis. Yeah. Then s equal integral, set the dx and in the middle point, opposite variable y. Yeah. And the range is related to x. Okay. I can rewrite usually in the assumption this is y equal fx. So you should change function in terms of x to calculate this equation from a to b. Specifically, this is fx dx. This is same. Okay. If we want to find the reason in terms of y-axis, you should set like this, dy, and put the opposite variable x. And the range is set about y-axis. Usually in assumption, x equal fy, so you should this fy, you should change like this, dy. Then you can calculate this equation. Okay, let's expand this area. Yeah, vertical slice. If there are two graphs, like fx is above or gx is below, let's look at this graphically. This is fx. This is gx. If we want to find the reason, enclose the reason like this. The range is a, b. First, you should find the area of fx. Integral from a to b fx dx. And subtract like this gx. Gx is, the range is like this. Fx is like this. Gx is here, pink. Yeah. So this is fx area. yeah, GX area is like this. Then you can find the enclosed area here. Yeah, here. So I can combine this fx minus 3x dx. I approached this concept graphically. Let's memorize this formula. Let's start the above equation as I want to find the area in terms of x-axis. So set integral. The range is AB dx. And plug in opposite value y, opposite variable y, and extend this function if there are two graphs, y2 or y1. Yeah, AB y2 minus y1 dx. In the exact assumption, this is fx, this is 3x. So I can rewrite integral from a to b fx minus 3x dx. Okay. Usually, you will utilize this form. Yeah. Okay. Look at the horizontal slice. Yeah. Yeah, look at the assumption. Fy is on the right, gy is on the left. Let's access graphically. This is Fy. This is gy. Okay, the range is C, D. I want to find the enclosed area. So first you should find the Fy. This is Fy. Yeah. So S equal integral from C to D Fy dy minus integral CD gy dy. This is this part. This is yeah, this is this part. And you can get the area here, this part. This is a graphical method. Let's memorize this formula based on the above formula. If you want to find the reason in terms of y-axis, you should set like this, dy, and set the range of dy, y-axis, c, d. Okay, and plug in the variable, opposite variable x. Let's expand if there are two graphs, x2 and x1. So integral CD x2 minus x1 dy. This is right. This is left. Yeah. So in the assumption, this is Fy, this is Gy. So we can rewrite from C to D Fy minus Gy dy. Oh, it is important. This is above, this is below. In the case of x-axis, you remember this, above minus below. In the case of y-axis, right minus left. Keep in mind this concept. Okay, let's solve this problem with me. Follow me. Okay, look at the problem number 4. The area of the region enclosed by the curve y equal 1 over x minus 2 and the x-axis and the lines x equal 4 and x equal 5 is. Let me draw this graph. This graph is like this. This graph has the asymptote x equal 2. Asymptote generate where x the denominator is 0. So this part is 0. So this hyperbolic graph is like this. The range is x equal 4, x equal 5. The reason is like this. Let's apply the reason formula as equal integral. I want to find the reason in terms of x-axis, so dx. This part opposite variable y. This range is in terms of x. So from 4 to 5 like this. Plug in this function instead of y. So integral for 5, 1 over x minus 2 dx. Okay. Let's apply the substitution integral. Follows these steps. First, substitute. Second, differentiate to find differentiate this above equation to find dt in place of dx. So dt equal dx. Find the changed interval. So t1 equal x1 minus 2. X1 is 4, so plug in this value. 4 minus 2, this is 2. T2 minus x2 minus 2, plug in this value. So 5 minus 2 equals 3. So yeah, I can rewrite integral. This is 2, 3. This is here t. This is t. This is dt. So I can rewrite. This is 2, 3, 1 over t dt. This is ln t. 2, 3. Plug in this value, ln 3 minus ln 2. The final value is ln 3 over 2. Look at the problem number 6. The area of the region enclosed by the graph of x equal y squared plus 1 and the line y equal 2. And the first quadrant is, okay, let's do this graph. X intersection is 1, the line y equal 2. The area is this. So I want to find the region in terms of y-axis. So s equal integral dy. Plug in opposite variable x. Okay. This range is related to y. So the range is 0 to 2. So integral, plug in this function instead of x, y squared plus 1 dy. This is 1 over 3, y cubed plus y from 0 to 2. Plug in this value. So the answer is 14 over 3. So D. Okay. Look at the problem 8. Yeah. Let R be the reason between the graph y equal e to the power of minus 3 times x and x is 4. X is more than 2 or equal to. The area of R is Let's draw this graph. This is the exponential graph. Y equal, this is 1 over e to the power of 3 x. This part is more less than 1, so I can draw this graph like this. This is y equal e to the power of minus 3 times x. I want to find this part. Yeah. This graph approaches to x-axis. So the range is from x2 to infinity. I want to find the reason in terms of x-axis. So s equal integral dx. Plug in opposite variable y. So the range is 2 to infinity. Okay. So I will substitute instead of infinity. So 2b approaches infinity. And plug in this function instead of y, e to the power of 3 times x dx. Okay. Let's calculate this formula. Limit b approaches infinity. This is minus 1 over 3 e to the power of minus 3 times x from 2 to b. Plug in this value. Limit as b approaches infinity, minus 1 over 3 e to the power of minus 3 times b minus e to the power of minus 6. So minus 1 over 3 limit like this, 1 over e to the power of 3 times b minus 1 over e to the power of 6. Yeah. As b approaches infinity, this value is 0. So minus 1 over 3 minus 1 over e to the power of 6. So 1 over 3 times e to the power of 6. So the answer is A. Okay. This is improper integral. So when you see this infinity and the interval, you should change like this unknown b and extract limit and apply. Look at problem number 9. The region in the plane is bounded by the graph of y equal 1 over 2 times x, the x-axis, the line x equal 3m, and the line x equal 4 times m is more than 0. The area of this region. Okay, let's draw this graph. This is hyperbolic graph, with the asymptote y-axis like this. And the range is x equal 3m, y equal 4 times m. The range is like this. Okay. I want to find the reason in terms of x-axis. So s equal integral dx. The range is 3m, 4m. This position is opposite variable y. Okay. Plug in this value instead of y. So 3m, 4m, 1 over 2 times x dx. Extract 1 over 2, integral 3m, 4m. This one you already know by using the integral formula. So 1 over 2, this is ln x. 3 times m, 4 times m. Plug in this value, ln 4 times m minus ln 3 times m. So 1 over 2 ln 4 times m, 3 times m. Divide by m on both sides, 1 over 2 ln 4 over 3. Oh, sorry. Yeah. So this is the final answer. This answer is not dependent. This M, but there is no M. So the answer is A is independent of M because this answer is not included M. So yeah, I finished this problem related to the reason about x-axis and y-axis. I'm rooting for you. Good luck. Bye bye, everyone.